So next up in our video series is commenting. Commenting is a very important thing that you would do in your Apex code or in any code that as a developer you would write. Commenting is very, very important. Why? Because it is a way of telling other developers what your code is doing. A good code comments help another developer to understand what exactly this code is trying to do. Otherwise, becomes extremely difficult for a person who has not seen that code ever to understand what this particular line of code is trying to do. So always, as a good developer, as a best practice, add those single line comments to explain what exactly it's happening. There are two types of comments that you could add, a single line comment or a multi-line comment. A single line comment would have double forward slash added to it. A multi-line comment would have a forward slash with an asterisk sign, and then it would end with an asterisk sign and then a forward slash. Let's see that how it shows up in the developer console. So let's go to our developer console. We want to see. Let's create a new class. Let's call it training session 5, and then we'll do our basics. So what is it? Public static void method. And now here I'm going to give a single line comment. What that comment is, this is method. As you can see, the color of this particular line has changed because it has these two forward slashes. These two forward slashes basically mean these two forward slashes imply to the compiler that don't read this line at all. Whatever is written here, compiler will not read it, compiler will not compile it. So hence we can write like a real life language or a sentence so that another developer could understand it, but compiler will not read it. Similarly, if you want to write like a multi-line comment, so we would create something like this. And as you can see, the moment I have added that star next to it, all of my class has become, grayed out. And that's the sole reason why, this is called a multi-line comment. So let's call it this is a class. I'll press enter so that I can go into the next line. And as you can see, there's another asterisk which is developer console has added automatically, but you don't need to bother about that. And I'll just call it, this is a class written in a training session for understanding commenting. Now, what I can do is I can close the comment here as well. And as you can see, the moment I have closed the comment, the color of rest of the lines has changed. Or what I can do is I can do it here as well, like this. So that would also work. You can close it on a new line or you can close it at the end of it. As a best practice, what we do is we do it here like this. Yeah. And you can add a space to make it more readable and understandable. Now, if you save it, all of this is saved and this is a single line comment. So that's a way of adding comments to your Apex code. Conditions. So conditions are very, very important. Without conditions, you cannot write any code in any language for that matter. There has to be a condition. If X happens, do Y. And if Y happens, do Z. Something like that would always be your logic. That's always there. In order to write any code in any language, you have to come through to if and else conditions, and you have to come through loops. We'll understand if and if conditions, basically conditions first, and then we'll go into loops as well. So what basically happens is, in a real life scenario, a business team will come to you as, a tech lead or as a business analyst will come to you and say, we want this particular solution to be implemented and we want this to happen in Salesforce. And then your business analyst would gather all the requirements, and then your technical architect is supposed to convert those requirements into a technical solution. right? When they convert this requirement into a technical solution, what exactly they do is they convert those requirements into if and else conditions. But they would give you in a natural language, like if this happens, or in a flow chart, like, if A happens and make a decision, like if A is greater than B, then do this. If not, if it is false, then do C, something like that. And if C doesn't happen, then do D, and so on and so forth. So they would give you a flow chart. You would understand that flow chart and put it into code like an if and else conditions like that. And that's exactly what we are going to understand now. So the first one is it's an if condition. So if the condition is true, do something. We are just talking about if the condition is true right now. We are not talking about anything else. So let's say we have two integers here. Let's call it integer A equal to 10 and integer B equal to 20, right? Now what I'm saying is if A is less than B, then do system dot debug. Let's say B is bigger, right? And then we would also do, let's run just till here, and then we'll add one more if to it, and then we'll see how we can optimize it. So I'll just change this here to our class name, and the method name is still the same. We'll execute it. Don't worry about that for now. We'll just execute it. Let's see what happens. Where is our debug log? Here's the debug log, and we got B is bigger. Why? Because A is 10 and B is 20, so obviously B is bigger. Let's add another condition, and let's say A is greater than B. So if A is greater than B, then debug A is bigger, right? Let's do open execute and execute again, and let's see the debug. So now what I have got is B is bigger. So B, we have just got this statement, and this statement hasn't come, which is right in a way because A is not greater than B. So this statement will not come at all. This is totally fine and it is expected behavior. So all good here. So far, so good. Any questions you would have, please paste it in the comment and I'll get back to you. Or you can reach out to me on Trailmaker on thetrailmaker.com, and you can book a Q&A session with me, or post your question and I'll try to answer that at my earliest. So this is an if condition. If this is true, then do this. If this is true, then do this. In order to make this condition true, what we can do is we can make A as 30, right? If we do that, just for a second, if we see that, then what happens is, let me put debug only. Now you get the result as A is bigger. So that is happening. I'm just making it back to 10. And now we saw that this statement is also running as long as it is true. And this time this one didn't run. You can now understand what is happening and why the other one is not running, because this condition is not true. Now let's look at the next part of conditions, where we would have if condition and an else condition. So if condition is still this, right? And then we can add another else condition to the back of it. So where the if ends, we can add an else to the back of it. So if this is true, then do something. If it is not true, then do something else. In the first statement, what we can say is else system.debug and say A is big, right? I'm just trying to make it different from this one. And here, let's add else again, and we'll say system.debug B is big. For now, just see it like this, and then I'll explain you a better way of doing it, and why we would use if and else and not just if. Let the result come for a second and we'll see. So we have got B is bigger and B is big. So we have got two results this time. B is bigger and B is big. So in this case, the if statement was true. So this condition ran. And in this scenario, if statement wasn't true, which we know, Hence the else statement ran. So far, I think it is very simple to understand. If true, if the condition is true, then do whatever falls within this block of statement. If it is not true, then do whatever falls within this block of statement. So far, I think it is pretty simple. If and else, do this or that. Now we have understood we are using two conditions. A is less than B and A is greater than B. Now, if this requirement has come through an architect, then what he would say? He would say check for A greater than B. And if A is not greater than B, so, he would say if A is greater than B, then do A is bigger. If A is not greater than B, then do else. Then say, so if basically A is not bigger than B, then there are only two scenarios. Either A is equal to B or B is greater than A. Let's remove the possibility of A is equal to B for the time being for this particular instance. If A is greater than B is false, then let's say B is greater than A for just this instance. We'll come to that, but I'm just saying for now. And to make it different, I'm just writing big in a little different format so that we understand from which line we are getting the result. I'll just execute it again. What you can do is you can go from execute anonymous, or if you have already ran that particular line, you can say just execute last, and we would come here and see our debug logs. So you can see B is bigger, B is big, and B is big. So where has this come from? This has come from line 27. B is big. Why? Because if A is greater than B is false, which is false, then it has just gone into the else statement and it is doing this. So basically, what we can say is we don't want these two if and else, and we would just use one single else and get either A is big or B is big. So that is one way of writing the code. How does using if and else help? If we look at the original way where we were not using else and just using two ifs, so the system has to process the conditions twice. So first it would check for A less than B, and second time it would check for A greater than B, which basically slow down the code processing. Whilst if you would just do something like this, it would just check for condition once, it would optimize your code and make it run faster. Remember, as a best practice, as a good developer, whatever code you should write should use minimum CPU processing, and it should be faster, it should be simpler to read and quicker. So now what we can do is we can remove all of this for now and we just keep this. Now we should add one more logic, which we escaped initially, where A is equal to B. So now what we will do is, so we would add else if, and here we would put another statement, and what we will say. So you can either say, now we can check if A is less than B. So if A is greater than B, then obviously A is bigger. If A is less than B, then B is bigger. And if both of these statements are false, then what will happen? Then both are equal, right? So then we would say system.debug A and B are equal. I'll just save this for now, and we'll understand it what exactly we are trying to do here. So initially, if I just cut it for a second, initially we just did this. So that would just check the if condition, and then we added else without this if, escaped the option of being equal, and then we said do this. This time we have added else if. So if this is not true, then only check for this condition, otherwise don't check for this condition. And then if both of these are false, then obviously they are equal. This is a simplified way of writing it. This is an optimized way of writing the same logic. However, if you would write this logic just with if, then what you will write? You would write A is greater than B, then do something. Then you would write another if A is less than B, then do something. And then you would write another if A is equal to B, then do something. So in this scenario, you are doing three if conditions. You are doing, and every time whether A is greater than B or whether A is, not or less than B, all of these three conditions would be checked. So CPU has to check all of these three conditions. Whilst in this optimized way of running, if A is greater than B, it doesn't need to check the rest of the conditions here. If A is less than B, only then it will come here and check for another condition. And if it is not, then we it doesn't check for any third condition and just goes and does the outcome. So this is, what do you think? Would this be faster or this be faster? Obviously this would be faster because we are doing less conditions check. I mean, well, whilst you are just running this code, it won't make much of a difference initially. But when we run into complex logics and like hundreds and thousands of lines of code running together, that's when things like this does make a real difference. And trust me, they do. So we'll run it again and see what happens now. And we'll do debug. So it says B is bigger, which is fine. Let's try and make A bigger and see what result is coming. And does our code runs perfectly fine? So, we need to check for all the options. When we write logic like this, check for all the conditions, like if they are running perfectly as expected or not. So this time A is bigger. That's true. Let's make it equal to B, and then we'll see what is the output. We say debug only. So it says A and B are equal. So we've got all of these R3 results based on whatever value we are getting for A and B here, and how you can optimize your conditions. If and else, and then you can see the nested if and else, which I have just explained to you while writing the code as well. So condition 1, condition 2, and then condition 3, and so forth, so on and so forth. You can do it. I think for now, for this particular video, I think we'll stick to commenting and if and else and nested if and else conditions. They are very, very important. Practice them by in your Trailhead playground. Write some code and practice these if and else, because if and else is the base of any code that you would write in your life. So practice, practice, practice. If and else is very important. If you have any questions, reach out to me. I'm happy to answer those questions. Good luck in your Salesforce journey. See you in the next video.